All right, so today we're going to talk about vectors. Okay, so does anybody know what a vector is? Yeah, the guy on Despicable Me.
Magnitude and direction.
Magnitude and direction, that's exactly right. So the best way for me to really explain what that means is that a vector is used to represent a force. Okay, so if my pen was going to represent a force, it would have a direction. Okay, so it would be potentially pushing in this direction, and then the magnitude is represented with a length. Okay, so that would be the strength of the force. Does that kind of make sense? Okay, I wrote the word, or said the word length. I can't spell length. So you might give yourself a little hint that the magnitude is just simply the length of a vector. Okay. So the very first thing that we're going to talk about is how you draw a vector. Okay, so a vector starts at an initial point and it ends at the terminal point. Magnitude and direction. Okay, so you can see that this is a notation right here. You see that little A to B? That kind of looks like a ray. You've seen that notation maybe in geometry before. Okay, so that means that we're working with a vector that starts from point A and goes to point B. Okay, so A being your initial point, B being your terminal point. How are we doing so far? Okay, so the first thing I'm going to do is show you what a vector looks like, its form. So there's actually 3 different forms that exist. The first form is called component form. Let's see, we already talked about that. Component form, there we go. Okay, so what you should write down is that the component form, so component form, we have this. So v is usually the variable used to represent a vector. Okay, and what do you notice about this notation of a vector? What does it look like to you? It kind of looks like a point, right? Okay, so in the past we've seen a point represented with parentheses. A vector is very similar. The first value is representing your x, and the second one is representing your y. If you happen to have a third one that's in 3-dimensional space, that's your z. Okay, but instead of using parentheses, they use those kind of greater than, less than brackets. And that's how you know that they're talking about a vector. Okay. So do you understand the difference between a point and a vector? No. What's that? No? So do you see how they're like rigid instead of parentheses? Like, so a point would look like this, 2, 3, whereas a vector looks like this. Okay, so let me show you how you would draw a vector. Okay, so let's say they gave us vector v is going to be, let's just say 5, -2. Okay, so if you were going to draw that vector on a 2-dimensional surface, so this is a 2. You guys need to put your phones away, please. Okay, I'm going to kind of draw this like I would a point, but instead of just drawing a point there, I'm going to draw a vector from the origin to that terminal point. Okay, so my terminal point is going to be 5, -2. Okay, so to get to 5, -2, I'd go to the right 5. Yep, in component form. So I'll show you a different scenario in a second here. Okay, and then I would go down to, so my terminal point is going to be 5, -2. So my vector is going to start from the origin and go to that terminal point. Sorry, I did not draw that very straight. So that's a vector. When given in component form, we draw from the origin. So the thing that you do need to understand about a vector is that we can take a vector and we can move it around. So as long as it keeps its magnitude and direction, we can move it anywhere in three-dimensional space. Okay, so I could potentially take that vector and instead of starting at 0, 0, I could start it at 5, 3, and then from there just move to the right 5 down 2, and I would still have that same vector. Does that kind of make sense? Okay, so let's say in example 2, let's say my point P, and I don't know why they like to use P's for points. I guess P for point, maybe that's why. And let's say we're going to go to Q. What's that? So let's just say I'm giving you an initial point and a terminal point. 3. Okay, so if they're in parentheses, what are they? They're points. Okay, so I want you to find the vector PQ. Okay, so if I was going to draw the vector PQ, what would that look like? Where would I start? -1, 4. So I'd go to -1, 4. That's my point P. So that's my initial point. Okay, and where does my terminal point exist? 3, 7. 3, 7. I'm at 4, 5, 6, 7. So there's my terminal point. So it goes from here to here. Okay, so can you give me the component form of that vector? Okay, so how did you get that? How did you get 4? What'd you say? 3. How did you get that? Okay, so yeah, you're basically doing the distance between the x's and you're doing the distance between the y's. Okay, so just so you know, algebraically, if given 2 points, so let's just say, let's just make a generic equation. Let's say Q is x2, y2. I mean, they can use whatever variables. I'm just picking letters. Say that one more time. Oh. Yeah, so like your x is always the first value of your point, and then your y's are always your second value of your point. It's never going to be switched around. Like,
but will the answer always be like y1?
Yeah. Yes. I believe yes. So your x value of your vertex is just going to be your y, or your x2 minus your x1, and then your y2 minus y1. So the way I always remember this is you always do terminal point, terminal minus initial. I always have to say that to myself when I do that. Terminal minus initial, that's important, because if you go the other way, your vector will have the opposite direction. Okay. Okay, so you do realize that so far I've only done everything in 2 dimension?
Yes.
Okay, so the 3rd dimension, basically everything stays the same. It's just harder to visualize, which is why I haven't done it. But as far as like finding the component form, given a 3-dimensional piece, the 3rd piece would just be like z2 minus z1, right? Okay. Okay. So now that we understand component form, what do you mean what? What on what I just said?
No, I'm still confused on that second vector.
The second one? Like how I got the vector 4, 3?
No, because you did the x2 minus x2, right?
Yep.
Okay, I get that. How'd you get the line though? Like,
The line. So I start at P, and I basically draw an arrow to Q. And that's it. It's like you're drawing a ray. You see what I mean? So like point P would be given, point Q would be given, and I just draw the arrow. Oh. Okay. So the next thing you got to be able to do is how to find the magnitude of a vector. Okay, so magnitude is just a really fancy word for saying length. Okay, so write down this one. Do you notice that they give you two different definitions? Okay, why do you think they give us two different definitions?
Throw a curveball.
Not. I wouldn't call it a curveball. I would say they're just kind of covering all your scenarios. Like, what is the first little equation? If you were going to use the first equation, what would have to have been given to you? It would be a component form. It would just be a vector. Okay, so this is if they give you a vector, given the vector. Okay, you just plug in your x squared plus y squared plus z squared. Okay, if they give you points, then use that one. Does that one look familiar to you at all? Like you wrote it down in the last section? Because what is it? What is that formula? You've seen it a million times before this. Well, maybe not a million. You've seen it many times. It's the distance between 2 points, exactly. And this just happens to be the distance between 3 points. So you might also want to write down the two-dimensional magnitude, because the ones that are given are both three-dimensional. So if you're given a component form in 2 dimensions, it would just be x squared plus y squared, right? But if you're given 2 points, it would just be x2 minus x1 squared plus y2 minus y1 squared. Okay, it is just literally the distance formula that you've seen lots of times before. So would you like me to do an example of finding a magnitude? Finding the distance between 2 points. Okay, do you want, let's see, I have an example of a three-dimensional one. Do you want that one? Right here?
Absolutely.
Okay. Might as well. I'm just going to steal this question. Since you've had practice before with two-dimensional distance, that's kind of cool that this is how simple it is to find three-dimensional distance. Don't you think? Maybe that's just me. Mike, are you with us? I just haven't heard you comment at all, and usually when you're paying attention, you comment.
Sorry. He's just really paying attention.
Are you got your headphones in? Are you listening to me or listening to music? Yeah, you're with us? You might be writing some notes down. I don't know. That's what I would do, but. All right, so how would I go about finding the distance between P and Q?
Use the point.
Okay, it's the point one. Good. So we have 2 points. So how is it going to start out? Okay. Good. So I can either go P's minus Q's or Q's minus P's. Remember with the distance formula, it doesn't matter which one goes first as long as I keep it consistent throughout the equation. So do you want to do P minus Q or do you want to do Q minus P? Okay, so P minus Q is what I heard first. So -3 plus 5, right? Minus a negative. And then what's next?
4 minus 2.
4 minus 2. And then what's last? and 1 minus 2 squared. Thank you. There he is. All right, so the first quantity is going to make, let's see, we get 2 squared, making 4. And then we get another 2 squared, making 4 again. And our last one, 1 minus 2 is -1, and -1 squared is 1. So if you add that up, that makes 9. So the distance between those 2 points would be a distance of 3. Pretty easy?
Yeah, so let's do it.
That's, for as far as magnitude is concerned, that's as hard as it gets. Yeah. No, I'm very serious. That's hard. We're not done yet, though.
Oh.
Remember how I said there's 3 forms?
Yeah. So that was only one.
I don't think it gets much harder than that, though. I really don't think it gets much harder. Okay? I'm going to give you a second form. The second form, I typed this up, so it kind of looks gross. Okay, but the second form is called Trig Form. No, this is a good form, I promise. Don't be upset about Trig Form.
Worst enemy in this class, I think.
Okay, so it says the magnitude of f, and then you have a component form, the cosine of the angle, sine of the angle. So the reason you like trig form, because I'm going to tell you why, and I promise you like it, because it is way easier to use than trying to figure out going into component form. So if you're given a magnitude, here let's say given a magnitude and direction, you want to use component form, or trig form, excuse me. Okay, now the trick behind, or the kicker on the trig form is that, which dimension is this?
The third.
This is 2.
This is only a 2-dimensional scenario. So trig form only works in 2 dimension because, now think about this, if I was going back and referencing the unit circle, okay, so if I have a cosine of theta, cosine always references which variable?
X.
The x. So really it's just like the x value. So think about this. So if I had a 45-degree angle, right? Okay, and it has a magnitude of, who cares, f. Okay, to get to that, I would have to go an x length and go a y length, right? This is literally going back to the unit circle idea. Okay, so to get there, I would do x being my cosine of theta and y being my sine of theta.
So it's basically just x and y.
Exactly, it is x and y. Yeah. Okay, so if they give you a magnitude and direction and ask you to write the component form of something, it's really easy because all you have to do is take your magnitude, multiply the cosine of your 55 degrees, and so forth. It gives it to you, given. So you would use it, yes, I happen to have an example right here. It's like I knew you were coming for. Okay, so here's a scenario of a small cart that is being pulled along a smooth horizontal floor with, no, there's no shadow we're talking about. With a 20-pound force making a 45-degree angle with the floor. Okay, so here is my, I'm going to draw a picture for you. It's going to be really good. This is my cart. Okay, so the cart is being pulled at a 45-degree angle. Okay, so this is 45 degrees. Can you tell me what the magnitude of that vector is? Huh? What'd you say? No, I didn't hear you because you might be right. Throw it out. No? Come on. Did anybody notice the letter that I chose to represent magnitude in this case? Why do you think I might use F for force? Okay, magnitude will also represent a force of a vector. So what is my magnitude of this vector?
F.
F, which is?
Force.
Okay, in this example, 20. Oh, wow, that was rough. 20, so it has a magnitude of 20. Okay, now this says, what is the effective force
20.
moving the cart forward? Okay, so the first thing I'm going to do is I'm going to put this into a vector form. Okay, so clearly, at least hopefully clearly, I have a magnitude and direction. So which form am I going to throw this into? Trig form. Okay, I'm going to use, how about V to represent my vector? So it's just going to be 20 times my vector of the cosine of 45 degrees and the sine of 45 degrees. Okay, now the question is asking me which force specifically is going to be used to pull this cart forward. Okay, so which force do you think they're referencing? Do you think that they're referencing this X movement or the Y movement? The X. The X movement is moving it forward. So which piece of this are we going to be looking at?
Cosine.
Just the cosine. So the only piece that I'm looking for is 20 times the cosine of 45. Because it's just the force that moves it forward, which is only the X direction. If they said upwards. Okay, so we could do this one using our unit circle knowledge. What's the cosine of 45 degrees? If you think about the ordered pair that exists at 45 degrees, what's the X value there?
I don't know, like 1/2-ish?
No. It's a square root of 2 over 2. You guys have forgotten that already?
Square root of 2 over 2.
Yes, you did. I tested y'all on it like last year.
Yeah, that's why you like last year. Dante, do you understand that when we do something?
I guess I should do it again, huh?
Probably not.
Next year I'll put that on my to-do list. Test that again. So if I have 20 divided by 2, this would be 10 square roots of 2, right? Shoot.
Why don't I have
Oh my
45
gosh.
on my unit circle that you gave me?
Turn it over.
It's rigged.
Let me see it. Oh, you only have 3060. Did I give that to you?
I don't know where I got it.
I don't think I gave that to you. That's only like half of the circle. I'll print you out a better one. You gotta throw that one in the garbage.
What?
You need to throw that one in the garbage. You're missing all your 45s on there.
Yeah, I do. Straight up headed to the trail.
Alright, here's, I think this is the last piece. No, actually we have 2 pieces left. So this stuff is like super easy, but there is kind of a lot. Yeah, you're right, there's 3. Okay, so, where did I go? I lost my... Oh, okay, so the next part is just understanding how to add and subtract vectors. Okay, so if you look at this, I feel like instinctively if I asked you to add 2 vectors, you would probably be correct in that assumption. Okay, so if you were going to add 2 vectors, what do you think you might do? Plus what? Be more specific. You would add like what pieces together, do you think? Yeah, you add the x's together, and then you add the y's together, and then you would add the z's together if there happened to be any. Okay? So algebraically, adding vectors is really simple. Okay, so I want to show you an example of adding vectors, and then I want to show you what it looks like graphically. Just so you can see, this is actually kind of cool. What number are we on? Example 4.
We're on example 2.
Oh, really? I don't know. Okay, so let's say our first vector, we're going to call our first vector u, is -2, 5. And our v vector is 3, 7. Okay, so if I asked you to do a u plus v, what would our resultant vector be?
1, 12.
1, 12.
It is.
Okay, so now watch how I do this graphically. Okay, if I'm going to add 2 vectors graphically, I start by drawing the first one off of the origin. So u is going to go to the left 2 and up 5. Okay, so there's my u. Now when I add 2 vectors together, I add them tip to tail. Okay, do you see what I mean by saying tip to tail? Okay, so if this is my vector, the arrow is my tip, and the button is the tail, the starting point. Okay, so that means that if I'm going to add v, I'm going to start at the tip of my u vector. So I'm going to start right here. You see where I'm at? I was trying to use a different color. And I'm going to go to the right 3, from there, to the right 3. 1, 2, 3. I'm losing my ability to write. And then go up 7 from there. 1, 2, 3, 4, 5, 6, 7.
After we're done here.
No. Okay, so my resultant vector is going to start from my initial point and end at my terminal. So that red vector, you can just leave that there, thank you, is u plus v. So check this out, you guys. If I was going to do 112 and draw it from the origin, do you see how that is exactly the same as drawing it tip to tail? It went to the right 1 and up 12. Okay. Okay, do you want me to do an example of subtraction? I will tell you subtraction, instead of tip to tail, you go tail to tail.
Hold on.
Do you want me to do that example with the same 2 vectors? Yes.
We do
It's
one
just a
for
quick
the
drawing.
homework. It's a subtraction.
You just draw, they just give you 2 vectors and you just draw them tail to tail with the resultant. It's pretty easy. And if you get stuck, you can ask me. It's not super hard. Okay, just so you know, the properties of vectors, I would not write this down, are the exact properties of algebra. Okay, which means if I add 2 vectors, it doesn't matter which order I add them. Okay, that is the commutative property, that very first one. Okay, if you add 0 to a vector, it's just the same vector, right? All of those are algebraic properties.
Which one is the distributive property?
Number 9.
Yeah.
Okay, so in my opinion, I don't think you do, because I feel like you already know this. Okay, so I'm not going to do an example of that. Yep, that's not in this one. Multiplication is a little bit different. Let's go different.
AKA.
I don't trust that.
I don't think it's harder, it's just different. It's just not an instinctive thing. Okay, last form. Last form is called standard form. So this is a very interesting form. In my opinion, I don't really understand why they have this because they use it. I don't know, because they're gonna give you questions about it and I want you to know what it is. Okay, so for standard form, I can write this out in my handwriting so it might look better, but we're gonna have AJ plus B, or AI, my bad, I, J, K. So all that's happening is instead of it written in like component form with parentheses, they put it into like an algebraic form where you can add like terms together. Okay, so let's say I had a vector u and it was like -2i plus 5j minus 3k. What would the component form of that vector be? So the I is in front of, or the number in front of the I is the x, the j is the y, k is the z. Yeah, -2, 5, -3. That's it. Yeah, I kind of agree with you. I don't know really why they have, I don't know. But they use this form, I don't know, maybe there's more stuff with forces in physics that it's easier to use. I don't know. That's all I got.
Why does it only give us the X's?
What? It doesn't just give you, the I's are the X's, the J's are the Y's, K's are the Z's. Yep. It's always I, J, K. So I's is with the X's. Yeah. Okay, so the last thing that we're going to talk about, this is it, is a unit vector.
But also,
What?
A unit vector. Okay, so the first thing that you need to understand is what is a unit vector. You guys still with me? I'm almost done.
Vector is
That's actually the formula for finding a magnitude or a vector. But just so you know, a unit vector. Okay, so a unit vector. Oh, my bad. I'll just wait for you. We good? Okay, so a unit circle. When we were working with a unit circle, why do you think they used the word the unit? What do you think the unit is referencing? How many units do you think that they're referencing? One unit. It's one unit. So on a unit circle, the one unit is referencing the radius of the circle. Okay, for a unit vector, we're trying to make a vector with one unit as a magnitude. Okay, so you could write that down. A unit vector is a vector with a magnitude of 1. Okay, so what they're going to do, so we'll just say unit vector, unit vector, is always going to be the vector divided by its magnitude.
Well, isn't that just
Yeah, that's
those both these?
those are both v's. Yeah, so for given vector, the vector divided by its magnitude. So I'll do an example so you understand the notation.
Magnitude always one.
Oh, so let me explain that. Okay, so they're going to give you a vector. Okay, so let's say they give me this vector, and this vector has a angle or a direction of 45 degrees and a current magnitude of 5. So what they're going to say is write the unit vector with the same angle or the same direction. Okay, so I'm going to find the vector and then just basically cut this cut it divided by the magnitude and then divide by 5 in this case. And that will give me 1 unit.
Okay.
Okay, so here's a, yeah, I guess we could do this one. That's fine. Okay, so this says, I think this is one of the problems on your homework. Well, similar to. So it says find a unit vector for the vector that's going from this point to that point. Okay, so the first thing that we have to do is take this vector and put it into component form. So first of all, what are they giving to us? 2 points. So to find my vector, how am I going to find the component form? So you're thinking distance. I just want my vector form. So remember, this is where I do terminal minus initial. Terminal minus initial. So which one is my terminal? Which one is my initial? P2 is terminal. Initial is P1. So I'm just going to subtract each of the corresponding values. So I'm subtracting my x's, subtracting my y's, subtracting my z's. Okay, so for my x, I'm going from 1 to 3, so my distance is going to be 3 minus 1 is 2. And then 2 minus 0, and 0 minus 1. Does everybody follow that? Okay, so there's my vector. Now I need its magnitude. So how do I find magnitude? That's your distance formula. Okay, so since I'm given a component form, I'm just going to do x squared plus y squared plus c squared and square root that. Okay, so it's going to go 2 squared plus 2 squared plus negative 1 squared. So we get 4 plus 4 plus 1. So we get square root of 9, which makes 3. Okay, so my unit vector, all I'm going to do is I'm going to take my vector, so 2, 2, negative 1, and divide by my magnitude. Okay, so if I divide by 3, what is that the same as doing? Multiplying by 1/3. So really all I'm going to do is I'm going to take this 1/3, gosh dang it, and this is what's called a scalar. So if I have a scalar that's being multiplied by a vector, what do you think I would do? Distribute it. That's exactly what you do. I would just simply distribute this through my vector. So it's just going to be 2/3, 2/3, -1/3. So that would be my same vector that has the exact same direction as the v vector, but its length is only 1. Okay. Okay, so that's it. Do reference this little thing because you might be asked about this kind of question. If they ask you to find a speed is referencing a magnitude. Yep. Okay. All right, so your homework is one out of the textbook. So it's in OneNote. So you have 2 through 36 evens.